Alright, ladies and gentlemen, welcome back to another round of PreAP lectures. Today we're going to be taking a look at atomic radius. Hopefully you understood the Coulombic trends lecture and some of that stuff we went over in class made a little bit of sense to you. If that's the case, this is probably going to be relatively simple. I just need you to pay attention to the vocabulary that I use and be able to justify the atomic radius. So let's start off by defining what atomic radius actually is. And so atomic radius is essentially just the distance from our nucleus to the outermost valence electron. So atomic radius is the distance from the nucleus to our valence electrons. And when we talk about radius, your mind probably wanders back to your math class, and so you have to really think about it's the same thing. Right? So the radius from the center of the circle to the outermost part of the circle, it's the same thing. And this is another reason why it's so easy to use our Bohr diagrams to kind of picture what's going on at the atomic level. So, and we have to understand a bigger radius means that we have bigger atoms, all right? We're still going to be using Coulomb's law, so we're still going to be facing the forces proportional to charge 1 over charge 2 divided by my radius squared. So this still comes into play. So the same Coulombic attractions that we talked about in class, that positive-negative interaction between the nucleus and our valence electrons, that's still in play here, okay? So let's jump right into it, and let's take a look at some groups. All right, I'm going to be looking specifically at group 1A. And so group 1A, I'm actually going to start with lithium. So that's in the second period. I'm going to do sodium, and I'm also going to do potassium. And so these are the three group 1 elements that we're going to talk about and we're going to discuss here. And remember, just to make sure you're on the same page as me, groups are my vertical columns, right? This is an up and down trend that I'm looking at here. So let's go ahead and draw a Bohr model. So if we go and look, I'm going to go ahead and label the periods over here. So it's period 2, 3, and 4. And so just so we can make sure that we get the right number of energy levels drawn. All right, and so lithium, if I'm going to put the nucleus there, I'm going to go ahead and draw 2 energy levels. If I'm doing sodium, I'm going to draw 3 energy levels because I'm in period number 3. So hopefully you're starting to see the trend here. And guess what? Within groups, as we add energy levels, our atoms get bigger. So as we add energy levels, our atoms get bigger. And for potassium, guess what? Guess how many energy levels I'm going to draw? Yes, the correct answer would be 4 energy levels. And you'll notice, even though I've got some sloppy circles there, essentially with groups, the thing that you're going to want to know, groups, and write it, groups, added energy levels increase the radius, right? For my groups, added energy levels increase our radius. And so the general trend for groups is as I go down the group, I'm adding energy levels and my atoms are getting bigger and bigger and bigger and bigger because of those additional energy levels. Now, within a period, and so now what we're going to do is we're going to take a look at side to side, and I'm going to go ahead and put magnesium. We're going to do period 3 and aluminum. Well, if I drew these, it's hard just to take a look at them because all of them are going to have 3 energy levels. And so notice now I cannot use that as my go-to which one's bigger. Now remember, back with Coulomb's law, what we're going to take a look at here is the force is proportional to charges 1 over times charge 2 over radius squared. Well, notice my valence electrons on these, within a period, my valence electrons are found on the same energy level. And so you want to write that down. Valence electrons are found within the same energy level. So for period 3, all of my valence electrons are found on that 3rd energy level. So my R squared part, right, is going to be the same within a period, right? And it's because those valence electrons are on the same energy levels. Now, this is where we start to get difference, right? The nuclear charge is increasing across a period. And so what I mean by nuclear charge is sodium has 11 protons, magnesium has 12 protons, and aluminum has 13 protons. And so notice the charge of my nucleus is getting larger as I go across that period. And guess what? Over here, this is where we're going to see our charge get bigger. So I'm going to have a larger Q, which means, and let me put this, across period. And this has to do with the addition of a proton as I move across, right? And so you can see, just basic number sense, the top of that fraction or that ratio is getting larger, and so my force of attraction is getting larger. And then we all know how our magnets act, right? The larger that attraction, the more those electrons get pulled in onto the nucleus, right? And so what happens is the radius will actually decrease as I go across the period, right? And so here we're going to put radius decreases across a period. It has to do with the fact that that nuclear charge grows, that force of attraction grows as I grow across a period, and those electrons get pulled in tighter and tighter and tighter to the nucleus. All right, so some pretty simple stuff. Again, if you understood everything that we were doing in class today with the Coulombic charges and forces of attraction, you're probably pretty good at this point. If you do have some questions, make sure that you get them written down. Come to tutorials, come to class, we can get those discussed and get them out of the way. But please make sure, this is not just looking on a periodic table and picking based on where they're at. We actually have to justify these trends. And so be sure that you can actually use some justification. Most of the time we're going to compare one to another, and I'm going to say, hey, make your claim, show me some evidence, and give me your reasoning behind why you're choosing one over the other. So make sure that you can do that. Make sure that you've got that kind of stuff down. All right. I will see you in class.